Hello my friends, and welcome back to another live programming video. Today I wanted to do two things actually. First of all, I wanted to try out the new RustRover IDE from JetBrains. If you've watched some of my previous videos, you'll know that I use IntelliJ IDEA with the Rust plugin, so I'm excited to see, what is different, what is improved in this standalone IDE. In terms of what we're going to be doing today, I thought it would be interesting to implement the scanner from crafting interpreters in Rust. So if you don't know, this is an excellent book. It is available in print. I have the print copy as an ebook, and also it's available for free on the web. So there is a language called the LOX language, which is, it has a whole chapter dedicated to it. And this is the language that this book implements. So there are a couple of parts to the book, right? So you have the tree walk interpreter, then you have the bytecode virtual machine, and it's just split into all the things that you need, right, to craft an interpreter, a compiler, all of that sort of stuff. So we're going to start here, section 4, scanning. So it says the first step in any compiler or interpreter is scanning. The scanner takes in raw source code as a series of characters and groups it into a series of chunks that we call tokens. These are meaningful words and punctuation that make up the language's grammar. So that's what we're going to be doing. We're going to be taking basically strings and making them into tokens that are machine readable. So this whole book is set out to be implemented in Java, and all the examples are in Java. I haven't used Java for a while. I was considering doing this in Java just to refresh, but then I thought, you know what? Why don't I create a video in which people who are familiar with Java, with C#, with TypeScript, people who are familiar with those languages but have an interest in Rust, why not create a video that gives them a little bit of an idea of what it's like going from those languages to Rust? So we're going to call this new project LOX. There we go. Let's deal with those automatically. And yeah, let's turn on cargo check. We'll run that on the fly, on the stable branch. And then maybe we don't need to have bacon running for this, because usually I run bacon to compensate for the slowness of the Rust plugin for IntelliJ. All right, let's get started. So it says here, this is our first real chapter. We need to sketch out the basic shape of our interpreter, JLOX. Everything starts with a class in Java. Luckily, that is not the case in Rust. When you init a new project, you'll have a main function. But I guess we can do something like this. We can create a struct called LOX. And we can implement some classes for LOX. Some methods on that later. So what do we have here? So we're checking the length of the arguments. So the first thing that we want to do is figure out how do we get the arguments. This is a standard library function. You get args, and then you collect them into a vec. A vec is like a list or an array equivalent, let's say. So here you see I've done vec, angle braces, and then this thing in the middle, right? This underscore. This underscore says infer the type, and you can see that RustRover here has determined that it is a string. Well, I think it's the language server that determined that. So if I did something like vec I32, we'd get an error here, right? Because you can't build a vec I32 from an iterator over elements of type string. So you can do this explicitly as well, but you'll probably get in the habit pretty soon of doing this when using common functions like the args function. So if args.length is greater than 1, so one thing that is a little bit different is that the command, so wait, let's, I can actually show this. So we're going to print line args. We're going to debug print that out. I don't want that. Let's see if we can run this. Args. There we go. And so we can see that we have one arg here. And this means that actually the executable that is running is the 0th arg, the first arg. So all of these numbers here, these checks, and these index retrievals, we need to bump them by 1 because Java, I think, does not have this as the 0th argument when getting the args from a command line program. So we're going to do if args.len is greater than 2, then we can print line usage jlocks script, and then we're gonna exit. I'm not sure what, I think exit is, yeah, exit is here. So we'll give it exit 64. Else if args.len equals 2, which means we have one argument besides this first argument, which is the executable. We're going to do run file with args1. Else we're going to do run prompt. And of course we haven't implemented those yet, right? But we will. Here we have a cannot move. So this is going to be a string. We're going to clone that string. Or actually, maybe we don't even need to do that. Maybe we can just take a reference to that string to avoid cloning it. All right, so why did I have locks here? Actually, you know what? We don't need this. We don't need this class. Maybe we can come back to it and bring it in later, but I don't think we need it. And this actually, we don't need that import up there either. I mean, this is a style thing that I prefer to have it like this. So stick that in a text file and you've got some stuff. Great. The next thing we need to implement is run file. So let's implement a function called run file. It can, so in Java it throws an exception, which means here it's going to return a result. So I'm going to bring in the anyhow crate, which is my favorite crate for dealing with errors like this. So we're going to have run file, which takes a path. Maybe this will be, we'll parse this into a path instead of just having a string. And it's going to return a result, a void result. So these curly braces here are the equivalent of void here. And this result is the equivalent of throwing an exception. I mean, in very, very broad terms. So the first thing that we want to do here is read the the contents of the file. So luckily we have, in the standard library, we have read to string, and that takes a path. It also returns a result. Which I need to use anyhow, result. So this is going to be let content. So we have our content from the file. And then finally, we need to do run on whatever that content is. And instead of cloning the string, we'll take a reference to it. And once that is done, we can return OK. The next thing we need to implement here is run prompt. So same thing again, new function. This is also returning void. So we'll do result. So what's happening here? We're getting input from standard in. So in Rust, I believe it's something like standard IO standard in, and then we can get lines. So let's make this a variable, lines. And then it's looping over them. So I think here we can do for, let's call this lines actually, for line in lines. And so this also is returning a result, see? So we can actually do for OK line in lines. And so this will only run if there is no error. Otherwise it will skip error lines. So we've read the line, and I think we're just going to run because we don't need to do null checks here. And then this will also take a reference to that string. I think it wants to print out something. Actually, no, we're going to print this, and then we read a line, and then maybe like that. I know, we'll see. I'm not too sure about this, but definitely we need one first. I'm not sure whether the next, what do we call this? Prompt, where the next prompt will come. Well, that's cool. So both the prompt and the file runner are thin wrappers around this core function, this run function. Create function run. Ooh, that's nice. And it inferred, well, almost correctly. We'll have a stir run. So we're gonna have, this is gonna be our source code, right? So we're gonna have here a scanner. So we haven't implemented this yet, we will. So let's say we'll have a new scanner, which is going to take the, so it's going to be an object, right? So actually, no, we can do that. It's going to take the source. And then this scanner is going to scan the tokens. I think we might do this a little bit differently. Well, we'll stick to it and see how it goes. So we'll let tokens equals scanner.scan tokens. And then for token in tokens, we're not getting any completions here because we don't have any of these types, but we can still pseudocode it, right? So for token and tokens, we'll do print line token, and we'll do this semicolon and question mark to just do some debug printing so that we don't have to implement a toString or a display for this. So here we have run. Very nice. So actually, you know what? We probably want this to break, right? So we'll do match, line and lines, match line. If it is an okay line, then we will run on that line. Otherwise, if we have any error, we'll just return. Actually, I think we can break here as well. And that's gonna break us out. Cool. So, we've gotten most of this stuff looking good. Run, what do we have here? Run file, expected, but found. Okay, so we can also make our main function return a void result. And then run prompt. This, it says expected path but found string. So this is something new that we did ourselves. So let's bring this out and see if we can do path from, or rather path buff from path. I believe that dereferences to a path, so that's fine. And, you know, if we want, we can inline this as well. Cool, cool, cool. So now the next thing is the scanner. Well, I guess some error handling first, right? So it's a static method. So fun error. I'll call this locks error. So we're gonna have a line. Line. You guys, I'm getting confused looking at the Java. We're gonna have a message, which is gonna be a stir. And that's it, apparently. So this is gonna be calling report. I wonder if we can just do this all in one place. You know what? I think we can just use ePrintLine for this, so we'll skip this. We'll see that in the future. So we'll jump down to lexemes and tokens. So here is a line of LOX code. var is the keyword for declaring a variable. That 3-character sequence var means something, but if we yank 3 letters out of the middle of language like GUA, those don't mean anything on their own. That's what lexical analysis is about. So we want to end up with a bunch of tokens like this for every single piece of code that we throw at this scanner. So we are going to start by making this token type enum. So we'll make an enum token type. It has left paren, right paren, left brace, right brace, comma, dot, minus, plus, semicolon, slash, star. Then you have bang or bang equal, equal or equal, greater equal, less equal, identifier, string, number, and then we have some keywords, and, oh, missed one, and class, else, false, fun, for, if, nil, or, print, return, super, this, true, var, while, and end of file. So those are all of our tokens in an enum. So there are lexemes for literal values, numbers, and strings and the like. Since the scanner has to walk each character in the literal to correctly identify it, it can also convert that textual representation of a value to the living runtime object that will be used by the interpreter later. So location information. All right, let's try implementing a token now. So we'll have a struct token. We can't call this type because type is a reserved keyword. So we're going to call this token type, which is a token type. We're going to have a lexeme, which is a string. We don't have an object type that all things derive from in Rust, so we'll skip that. And then we'll have a line, which is an unsigned integer. I don't think we need a constructor for this. I don't think we need a toString. We can just derive debug for now. We should actually derive debug on token type as well, so that this all works together. And that error there just went away. The scanner class, I mean, you guys should definitely read this at your own leisure, but or maybe even read this before, or if you've done this before, maybe that's the best bet. It might be a bit easier to follow along. So we got now the scanner class, which is going to be a struct, which we will also derive debug on. And the scanner has source of type string and tokens, which is a vec of token. And what else do we have? So this one we will need a constructor because we need to initialize this vector. So we'll do impl scanner, function new. This is going to take a source, which is a string, and it's going to return a scanner. So we'll do self, source is source, and then we initialize the vector like that. We store the raw source code as a simple string, and when we have a list ready to fill with tokens, we're going to generate, the aforementioned loop that does that looks like this. So this is going to be, again, a method, scan tokens. I think this takes self because we need to operate on the source and the tokens. And because if you see here, we're going to be adding to that tokens array, we need to make sure that this in Rust is mutable, right? So we have a mutable reference to the self. So while self is at end, is not at end, we're going to set self.start to self.current We have not implemented these yet, so don't worry. And then we're going to do self.scan token. And then when we are at the end, we're going to do self.tokens.push, not add, but push a new token. And we can add the end of file. Actually, this is interesting. So our lexeme should be an optional string because EOF does not have a lexeme, and other things I'm guessing will not have a lexeme. So this is going to be none, and the line is going to be whatever is in our line state on the scanner. So, here we go. We have these new members on our struct. So we're going to have start, unsigned integer, current, unsigned integer, and line. We're always going to start at line 1. So we bring these into our constructor, 0, 0, and 1. And a lot of those errors have gone away, except for self is at end and self scan token because we have not implemented these yet. So we're going to implement is at end, and this is going to return a Boolean value, which is a bool in Rust. And we can do, we need to have a reference to self. This one is not mutable because we're not changing anything. So we're going to return current greater than or equal to self.source.len self.current. There we go. And in Rust, one of the very nice things is that the last expression in a block of curly braces is automatically the return value. So you can do this, but it's not particularly idiomatic. So we have is at end, and now we're going to recognize the lexemes. So we implement this scan token. Now can create method scan token. Yeah, nice. So we're going to have, to start with, we're going to have, let's see, char equals advance. We have not implemented advance yet. Advance is also going to be a method on self. And I'm pretty sure that's going to require some mutability of current, of source, of line. So let's make this mutable in advance. Then we're going to do a match statement. We're going to match on that char. And it's going to be a little bit tedious, but we're basically doing this. We're going to do self.add token. Again, we haven't implemented this yet, but we will. Left paren. Oh, token type left paren. Yeah, I don't want to do that. We can get rid of this too. So that's left paren. This is going to be right paren. We'll do the braces so we can change that to brace. Next, we're going to have a comma. We're going to have a dot. We're going to have a minus. We're going to have a plus. We're going to have a semicolon. And we're going to have a star. Nice. Again, we need a couple of helper methods. Indeed, we do. So first off, let's do advance. Advance returns a char, and I'm pretty sure this needs a mutable reference. this is one of the things I really do not like about Java and related languages. So the way this is gonna, I think the way that this is going to be evaluated is first it's going to increment the value of current on scanner, and then it's going to evaluate this bit, which returns the character at the I do not like this code. I'm just going to put it out. I do not like this code because it is not clear, and I think clarity is increasingly underrated these days. So let's make this a little bit more clear. So we can do that, I think, by let's collect all of the characters of the source into a vector. Let chars equals vec, and this is going to figure it out for us. Oh, figures out the return type for us, which is nice. And you know what? I should have functing working, but it's not. Nightly funct. Turn this on, please. Thank you. Right, so we have our characters. And what is happening here? So we're gonna return what are we gonna return? You know what? I'm not actually sure how to parse this. Well, so I think, wait, the advanced method consumes the next character in the source file and returns it. So it returns the, so, all right, let's just try this. So let, so we'll just say that this is chars self.current. Because I think if we're advancing, how is this going to work? Self.current plus equals 1. And then we're returning this. Right? Okay, maybe. We'll see. And then we need to do add token. Which is going to add a token type. And this has overloading, which I don't think that we need. We'll come back to it if we need it. So instead of this, we'll do lexeme string, because we don't have object. So our text is going to be let text equals source dot. I don't think we have a substring method. We'll just do this array lookup. This is also a method on self. Probably mutable. So we're taking self dot start. We're going up until self dot current. And source, of course, is also on self. And we need to take a reference to this. So we have the text, which I guess is also the lexeme. Oh, in that case, we don't even need this. The lexeme can just get looked up here. So this is the lexeme. And we're going to add to tokens. We're going to push to the back another token. And that token will be this. So lexeme, we're going to return our lexeme to string. think that looks right. So matches have to be exhaustive, so we're going to say unimplemented for the rest, which is just a fancy way of doing this error handling in Rust for now. I mean, there are a whole bunch, like you can panic, you can do an error print line, but for now, let's just go with unimplemented. Operators. So the next thing is we need to worry about multiple character operators. So we need to look at the second character before we decide if this is bang or bang equal. So let's do that. So we have bang. And what is this saying? We're doing a match here, right? Match is another function, which we'll probably have to give a different name to. But we're saying if, we'll call it matching equals, thank God there is no ternary. I do not like the ternary operator in most languages. So in Rust, you do it like this. Then we're going to do self.add token type is going to be bang equal. Otherwise, it's going to be bang. And we do this for a couple of things, right? So we also do it for equals. So we can have equal, or we can just have equal as an assignment operator. Then we have the same thing for the less than symbol. So this is going to be less equal. This is going to be less. And greater than or greater than equal. There we go. Now we need to implement this matching, which is, once again, a method on self. So you can see already, like, Rust is a lot more explicit, which makes it a lot harder to footgun yourself. So this is going to be matching expected is a char, and it's going to return a bool. So if self.is, oh, it's also a method on self. Self is an end, return false. Easy enough. If self.source, so we need to grab all of the chars again. We'll do this. What's going on with the formatting? Oh, my Rust font does not work. That's not great. Wait, maybe it's because I don't have... There we go. Now it's working. Okay, so we get the chars. So if... And we're here now. If... What the frick? Maybe we do this. So weird. Anyway, if source, oh, self.source chars a current is not expected, so current is again on self, return false. Otherwise, and so this is going to be mutable because we're mutating the value of current, self.current plus equals 1, and we return true. So that is our matching function. now also working there. Longer lexemes, so we can have oh yeah, this operator for division. Okay, so this can also be a comment. Okay, we do that. A comment goes to the end of the line. So while peak is going to be on self is not a new line, and when not at the end, we're going to do self.advance. Else we'll add the token slash. So in this case, we're never going to add a token because we're just ignoring the comments. Some scanners do stuff with comments. The one in the locks programming language in this book does not do anything with comments. So now we're going to implement this peak method, peak fun peak, which returns a char. So if not self.is at end, so if we're not at the end, return this char. Oh no, sorry, if we are at the end, return this char. Otherwise, we're going to get the chars again, and we are going to return the char at self.current. Cool. It's like advance, except it does not consume. Consuming being... Oh, okay, so if it's like advance but it doesn't consume the character, then this should be like this. So we return the current, and then we increment, i.e. consume. All right, that's good that that is clarified. So we have white space now that we don't particularly care about. So let's add these white space chars. What else do we have? T. And we're just ignoring them. We're doing nothing with them. And when we have a line break, what we want to do is self.line. We want to increment that. Cool. When encountering white space, we simply go back to the beginning of the scan loop. We want that new line to get us here so that we can update line. Our scanner is getting smarter. It is. So the next thing is we need to be able to handle strings, string literals, and these in the locks language begin with this thing. What do they call it? Double quote. So double quote. Here we're going to call self.string, which we have yet to implement, which is here. So let's see how we can implement that. I'm guessing this probably needs to be mutable. So while peak, self.peak, and actually we don't need those annoying round braces around everything. So while peak is not the ending double quote, and when not at the end, if peak is a new line, we'll increment the line. Otherwise, and we'll always advance. And we'll always advance if we're not yet at the final terminating double quotes. So that's this bit. Next we have if self is at end. We have an error, right? This is not cool. We have an error. So we'll do ePrintLine. Line unterminated string self.line. We'll report that error. So once we've gone through this while loop, and if we're not at the end of the file, it means that we have reached the final closing double quote, so we can advance. Trim the surrounding quotes. So we're gonna get the substring again. Self.source. We'll do a substring. How should we do the substring? Hang on. Add token string value, but. Where's my add token function? We're already getting the lexeme here and add token. So actually, I don't think this is like for that wacky object stuff that Java does. So we don't need to care about that. So we will self.addToken with self. Oh no, we just need token type string. And then we can advance. Yeah, I think that looks right. So yeah, like with comments, we consume characters until we hit the double quote that ends the string. We also, well, I don't handle it so gracefully, just an error print line if we run out of input before the string is closed and report an error. So the next thing is number literals. So we add something else to our match case. Oh, we got some errors here. Expected string, but found a stir. So we'll change this to stir. And we'll do source to string. Should really look at the errors every now and then. Scanner is mutable. Scan tokens, we don't actually return. We don't need to return the tokens because we can just get this from scanner.tokens. Yeah, that's nicer. All right, so we were going to get into digits. So I don't think here they're putting it in the default case. I don't think we should because we have this nice pattern matching, right? So we can say digit, which is we're just declaring a variable. If digit dot is which radix do I need to use for this? Is numeric? Is that what we want? Yeah, I think that's good enough for our purposes. So if digit is numeric, we're going to call number like we called string earlier, which we will implement next. Okay. So we go on back down and we have a new function, number. So this is a void function. We're not returning anything. So while peak, oh, we need self here. While self dot peak is numeric advance. Make this mutable. Look for a fractional part. If peak equals a fractional part and oh, we don't have peak next. I guess we need to do that. Peak next is numeric. We will consume the dot. And then we'll have a while loop while self.peak is numeric advance. And then finally, outside of this if, we will self.add token. Our token will be a number. Sweet. Now we need peak next. Peak next. If current plus 1 is greater or equal than source. Oh, we need to get the chars again. Because, so actually here's a thing y'all might not know. If I so if I do len on this, you can see it says returns the length of this string in bytes and not chars. So this is why we're getting the number of chars. In other words, it might not be what a human considers the length of a string. So this is why we're always doing this on the chars. So if self.current plus 1 is greater than or equal to the length of the number of chars in this string, we're returning a char here. Return this character. Otherwise, we're doing chars current plus 1. Self.current plus 1. Cool. And we've got our peak next. This is a function. Sweet, sweet, sweet. Now we have reserved words and identifiers. Let's add those in as well. So we'll have O. O can be a variable name or it can be or, basically. I mean, you can read this while I'm doing this. So if self.matching R, we're gonna add token type or. And then if it's alphanumeric, we're going to add this token as an identifier. So we'll have alpha if alpha is alpha alphanumeric. And we'll make a new method on scanner called self.identifier, just as we have for self.number and self.string. So function identifier. So while our while whatever we peak is alphanumeric, advance, and then when we're done advancing, we can add a token, which is token type identifier. We don't need those helpers because they're built into the standard library. Thank you very much, Rust. And now keywords. After we scan and identify, we check to see if it matches anything in this map. So while, okay, right. So what we're going to do here is we're going to do a match, right? So we're going to get the text. Why did I have the text? The lexeme. So we're going to get the lexeme. And we're going to match against it. And what are we going to do? What are we going to return? So this is going to return a token type. Let token type equals. So let me see. We'll start with and. Token type and. Sweet. We'll do the same here. Class. Else. False. For fun. If nil or print return super, but I haven't used that keyword in a long time. Thank the Lord for Rust. This again, bringing back nightmares. True var and while. So when we're looking at the identifier, right, so if it's none of these, so if it matches none of these, if it's anything else, then we say it's an identifier, which is like a variable name. So here, then we have token type. We return that. Sweet. Oh, we're at the end. That's it. It only took us an hour. So now let's see if this works, right? That is going to be the test. Does this let me do things? So what was the, this was it, right? This was going to be our test. Var language equals logs. And there we go. Well, this bit is a little screwed up, but check it out. Can I move this up? Yes, I can. So I gave the REPL var language equals logs. So we have token var, token identifier language, token type equal, which is the equal sign, token type string. String is a little bit funny. I'm not sure why it's doing that. Maybe I need to trim the... Okay, but it's close enough. Semicolon at the end, and then end of file. So let's see if we can fix up that string. So maybe we can trim this. Trim start matches. Is that right? Can I do both sides? Trim matches, yes. Let's see if I can get that thing going the right way. Where did you go? So maybe this goes here, and this goes... Like, I'll be honest, I'm not too worried about this. This is like the least of my worries. So we'll stop that, restart. Huh, still not printing, huh? Very strange. Maybe we do that here. Huh. Why you know? Why you know, my friend? Anyway, it doesn't matter. We don't need a prompt. So we'll do var language equals locks. And check it out. Now we have var language equals locks without the silly, what do I want to say? Without the silly additional double quotes. We trimmed that. I think that is very cool. Var integer equals 1. Same thing, var integer equal identifier 1, semicolon, EOF. That should be a number, right? That should be a number. Hang on, why is that not a number? Because digit needs to take precedence, I think. Var integer equals 1. There we go. So whichever one is first in a match will get hit first. Alphanumeric also encompasses numeric. So we have var identifier equal number, semicolon. Yeah, this has been a lot of fun. Yeah. So hopefully you guys, you all learned something from this. I definitely learned some stuff from this. Really, really cool exercise. Took me a bit longer than I thought it would. But this is really cool. And I think especially if you come from a non-traditional education background in computer science, if you didn't have the opportunity to take classes on building interpreters and compilers, definitely worth, working through this book. And also, I think once you have gone through this book once and you want to learn a new language or get comfortable with a new language, the concepts here are really transferable. Like, even though all of this is written in Java, like, you can apply this to a new language that you're learning. And, you know, some things will be a bit easier in a language, some things will be a bit harder. But, you know, it's a great learning experience to implement something that you already know how to implement in a different language. I think that is it for this video. So if you enjoyed this video, if you learned something from this video, please make sure to leave a like. Please make sure to comment. And of course, please make sure to subscribe to the channel. So this is my channel. I am very, very close now to 500 subscribers. That would be awesome. Usually, if you've already seen my videos, you know that I work on a tiling window manager for Windows called Komorebi. A lot of tutorials, all of the most popular videos. And also I have a playlist where I'm doing all sorts of live programming on this. So, there'll be issues on the GitHub repository, and I will implement them and I will fix them. And yeah, if you like my stuff, you can sponsor me on GitHub. Most of the sponsors are sponsoring my work on Komorebi, but if you find this sort of content interesting too, please do subscribe. That'd be very, very much appreciated. All right, that is it. That is me done for the day. I hope that whatever you all do today, you have a great, great day. And I hope to see you all back here next time. Goodbye for now.